All right, so law of sines. What's this about? So what we're going to be looking at, we're going to look at non-right triangles because everything's been right triangles so far, right? Like, oh, here's a right triangle, SOHCAHTOA, blah, 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 right? Even though it says law of sines, it's not quite using SOHCAHTOA, but SOHCAHTOA does play some role here. And I'll explain in just a sec. So this is called the law of sines. It's a formula. Very simple. Here you got a triangle, and it could be totally scaling or isosceles, or equal out, whatever. It doesn't have to be right triangle. What you do is you label the corners as A, B, C, and the side opposite of them as little a, little b, little c. Because clearly little a corresponds to capital A, little b corresponds to capital B, little c corresponds to capital C. What you do is you take the sine of one angle and divide by the side opposite. So this is called an angle side pair. So this right here, angle A and little a is called an angle side pair. You have an angle inside and they pair up. Likewise with capital B and little b, capital C and little c. And by the way, you don't have to have the side and the angles numerator. The side itself could be the numerator. It's really not. Now, where does this formula come from? Let me explain. It's not something I fell out of the sky. There's a reason why it works. So let me do a little, I'm a little surprised these notes don't show the derivation of it, because I think that is important to talk about. So I'm going to do the derivation for you guys right now. And if you squeeze it somewhere in the notes, great. If not, don't worry about it. It's all good. But you can just sit back and relax if you want. So here's the deal. And we just started looking, you're good. The notes are right there. So let's say I got myself a triangle like this, right? Now I'll call this A, B, C, little a, little b, and little c. And let's drop the altitude like this. And we call this D right here. And I'll put a right angle here, right? Obviously. Well, if you think about it, that's the height of the triangle, right? Correct, right? So, yeah. Well, so let's think about sine angle A. How would I write an expression for sine angle A? If I focus on triangle ABD, focus on ABD, not the whole thing, just ABD. How would I write this? Sine angle A be opposite over, so I would say H over C, right? Okay, that's H over C. I mean, that is SOHCAHTOA, clearly. All right, let's look at the other right triangle. Another right triangle. CBD, right? CBD is another one, right? So sine angle C is what? H over A, right? H over A. Okay, good. So sine of angle C is H over A. Isolate H in each case. You get this, and you get this. Well, both these equal H, right? So you can set both expressions equal to each other. Let's do it. A times sine A. Oh, sorry. C times sine A, because I can't read my own handwriting. C times sine A equals A times sine C. Does that make sense, what I just did? Okay, now I'm going to divide both sides by C. So those cancel clearly. So sine A equals A times sine C over little c. And at the same time, I'm going to divide both sides by A. Those cancel, and those cancel, and what do you get? You get the law of sines. So this is why it works. If you simply take the triangle and drop an altitude, and just use basic SOHCAHTOA, and because you split the two right triangles clearly, right? And just use basic SOHCAHTOA rules. Okay, sine of this angle is H over C, sine of this angle is H over A. Oh, okay, I said H in each case. Oh, let's sum each other. Oh, let's move things around algebraically. This falls into place. Where does sine B of low b come into play? You can rotate the triangle, draw a different altitude, and do an angle B. Same connection. So I'm not going to do that in the interest of time, but that's where it comes from. So this is called the law of sines. And this can be used to solve for missing sides, missing angles of any triangle. It doesn't have to be right triangle. It could be any triangle. You can solve for missing sides and angles, as long as you know some information about the triangle. Now, what information do you need to know? Let's talk about it. So let's see here. sorry. Okay. Let's go full screen. Perfect. Okay. So what information do you need to know to be able to utilize this formula or this relationship, right? If you know two angles and a side, then you're good, right? Like for example, if I know, well, let's go down here. If I know, and this is a little bit of geometry, right? I mean, I'm sure this is a couple years ago, or maybe yes, 2 summers ago if you did the geometry jump class. So angle, nope, angle, angle, side, angle, side, or angle, side, angle. Because guess what? If you know these two angles, are you gonna know that third angle? Right? Yeah. If that's like 40 and 50, then that's like 90 or 15, 60, 70, right? Or here, if I know these two angles, I clearly know what that's gonna be, right? And as long as you have a known angle side pair, as long as you have a known angle side pair, like that. You see that connection there, right? Angle side, like you can use the formula. Or here, like I know these two guys, I can use the formula. So it totally will work. And we'll do some examples, you'll see that in just a sec. Another situation that we'll have to look at, it's kind of funny. I don't usually use that word, but SSA or ASS, whatever you want to call it. That's when you have two sides and the angle is not between the two sides. You can still use law of sine because you know the angle side opposite each other. You know the side is angle, you have the known angle side pair. And then you can use law of sine to find like this is the angle and then keep going up. And again, we'll do some examples. I think when we do some examples will make sense. Right now, this may not make too much sense. It will, trust me. Now, if you have side, 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 forget about it. You can't use this law of sines business. If I don't know any angles, I cannot do law of sines, right? Because law of sines needs two angles, right? If I don't have any angles, I can't do law of sines. There's another rule called law of cosines we'll do next week. Or if I know side, angle, side, but I don't have a known angle side pair, like I don't know the side opposite this angle. I know the angles opposite the other two sides I'm given. You can't do that. Again, you have to use something called law of cosines. So you have to have a known angle side pair to be able to use law of sines. Jack, go ahead.
So you kind of like do like a line down the middle.
No, it won't work that way. No, unfortunately, because if it's not isosceles, then you can't. You have no clue. If it's isosceles, sure, maybe you could, then split afterwards. Now remember, the values for sine must be between well, we don't do negatives here necessarily. Yeah. The values for sine must be between 0 and 1. Because if you think about, I know I said there's no unit circle. I know I said that. But if you think about the unit circle, where's sine positive? In Q1 and where else? Q2. What's the angle measure from Q1 to Q2? 0 to 180, right? In a triangle, an angle could be anywhere from 0 to 180. You could have a 150-degree angle in a triangle or 120-degree. So, and we know that sine's always from 0 to 1 in the first quadrant or second quadrant, right? There's also a relationship between the angle and the opposite side, right? If you have a bigger angle, do you have a bigger side? Yeah. If you have a smaller angle, a smaller side, totally, right? So expect that. And we do need to be cautious. It gets really messy. There's situations where you may get no triangle, one triangle, or two triangles. This usually happens with SSA, or what we call the ambiguous case. I'll explain when we do some examples. You'll see what's happening. Ambiguous means you don't know, it's unclear. So when you give an SSA, sometimes it's not quite clear what kind of triangle is happening. I'll explain when we get there. But again, we're going to be solving for missing sides and angles using this formula, law of sines. So let's do a problem right now and work it out. Let's see how many examples we got here. We got 4 examples today. Perfect. And then we have a summary at the end. Okay, great. And then you could do homework after that, or you could just relax because I know it's been a long day. Well, let's try it. And try to draw it accurately if you can or to scale. Like 140 degrees is clearly obtuse. So let's draw something kind of like this here. We'll call this angle A. We'll call this angle B. We'll call this angle C. So this is 7. This is 5. And this is 140 degrees. Okay, before I even get started with law of sines, I know this is impossible. How do I know this is impossible? Not necessarily. Okay, so 140. Is 140 going to be the largest angle in the triangle? Yeah, because you only have 40 degrees left the other two. What's the opposite of 140? 5. What's the other side I'm given? 7. How can this be smaller than this side when this is opposite the biggest angle? That can't work, right? Wouldn't this have to be the biggest side? This has to be bigger than this side at least, right? It's the opposite of the biggest angle. So right now, but I'm going to work it out so you can see what happens. Sometimes you will get caught up in doing the form and not realize it doesn't work. I want you to see, but right after I know, so this process works out the way it does. It's an impossible, let me say this here. It's an impossible triangle. Because largest angle or actually, let me rephrase it. Largest angle is not opposite of longest side. That we know for sure. So let's work it out. But let's just work out, see what happens. So here we have this. I'll multiply both sides by 7. Please be careful with your fraction arithmetic. And this is where I use my graphing calculator app. I'm gonna bring them on with me. Let's see here. So switch to degree mode. Very important. You will be screwed if you stay in radian mode. And by the way, we're not doing any radians in this unit, just so you know. It's all degrees. Everything's all degrees in this unit. So make sure you switch because that would be really bad. And divided by 5. Okay, fair enough. So we get roughly 0.8999.
Does that mean we're gonna get a graphing calculator?
100%. Yes, 100%. You have to. You can't do it without one. Yes, correct. Now, how would you solve for b? What would you have to do to both sides? You have to do the inverse sine, right? That's how you undo a trig function. So if I solve it, inverse sine of that junk, I get 64.15 degrees. Okay, fine. Here's the problem. How can that be 64 degrees and that 140? We that will be shot our limit, right? We're supposed to be 180. That's well over 180. Now you're at 204.15. Then angle C is negative? That's strange. That just can't happen, right? That just can't happen. So yes, if you went through the motions and worked it out, you would realize all of a sudden, oh crap, this is not possible. But even then, don't even go, you don't even have to go this far. Just think about it. 140 and 5? No, because 7's longer and 7's not opposite 140. Doesn't make sense. So at this point, I would just kind of just stop and not go any further. If you want to go further, then you would find angle C by adding them all up and subtract 180, which you can't do anyway because it'll be negative. And then you have to law sines again to find angle side AB or side C, which is opposite angle C. So let's see when that is legitimate. This one is a legitimate one. All right, so let's draw. Try to be as accurate as possible if you can. A, B, C. So this is 20 because it's opposite angle B. This is 6. This is 25 degrees. Great. Okay. Well, let's work it out. So I'll start by doing this. Sine of 25 degrees over 6 equals sine B over 20. Does that make sense? What I just did? You could do angle C, but I don't know the side opposite angle C. So I need to do stuff that I do now. So there's four variables, and I know 3 of them, right? Yeah, Sean, go
Are we
ahead.
gonna get a formula sheet?
I think so. Yeah, maybe. Yeah, I'll get back to you on that. So, um, I'm pretty sure. I mean, honestly, as you do more and more of this, you just know it. I mean, okay, sine B. But yeah, there are going to be some really wacky formulas that we'll do later in this unit. So yeah, I think there should be a formula sheet. Yeah, it's 25 degrees. Sorry. Let me write that more nicely. And what's that going to be? Let's work it out. 20 sin 25 divided by 6. Uh-oh, we run into a problem. Okay, this can't work either. Because if you do the inverse sine of that, it's going to give you an error. So make sure I did it right. Just want to make sure nothing seems off here. Sine 25 over 6. Yeah, I did it right. Okay. So 20 is just way too large. This just can't work. So you get 1.409. 1.409. But the problem is that if you try doing the inverse sine, that's undefined. Remember, sine of an angle can't exceed 1. Can't exceed number 1. Just can't do it. So why is it explain why it's problem that works out the way it does? That's why. Should put in the box. My apologies. That's why. It's more than 1. Yeah, if it's more than 1, it just can't work. That would be a problem too, because it'd be 90 degrees. Yeah, because here's the thing. What is sine? It's opposite of hypotenuse, right? Because remember, sine of an angle is opposite of hypotenuse. So if that fraction equals 1.4, then what you're telling me is that the opposite side is bigger than the hypotenuse, which can't happen, right? So again, this is not possible. You have no situation, it's not possible. All right. I was hoping it would work out nicely, but I guess not. All right, now let's move on to example 3. Okay, I swear this one will work. All right, so let's draw this one here. We'll make this angle A. We'll make this angle B. Angle C. 105 degrees, 11, and 5. Oh, okay. We'll set up sine of 105 over 11. All right. You guys with me so far? We're okay? We're good? Cool. So let's punch it all in. 5 sin 105 divided by 11. Oof, okay, 0.439. I guess that seems reasonable. 0.439. And I do the inverse sine of that, which will be 26.04 degrees. All right, now we're cooking. What do you think angle C? How would I find angle C? What would I do? If I know this is 26.04. Yeah, totally, 100%. Thanks, Jack. Yeah, 100%. That's not hard. Which is, I'm trying to do my head, which you shouldn't, but 131.04, 48.96. Yeah, 48.96 degrees. So that's angle C. That's angle B. Okay, then lastly, sine of 48.96 degrees. Again, these are not terribly exciting problems. There'll be some word problems we'll do that'll be a little more cooler, either on Friday or next week. Right now, we're just doing a lot of the basics. Over little c equals, and I'll do sine 105 over 11 again. So I know that, right? Okay, I'm gonna need some space here. Let me get rid of this stuff here. I don't need that anymore. So cross multiply. And please be careful with your algebra. If anything, the only thing that really concerns me is when you're going through the motions, you might have like denominators and numerators mixed up. Things like that, right? Cross multiply, just to be safe, like, yeah, 11 times this, 8 times this. And then, like, don't cut corners, because sometimes, like, you so accept, I'm gonna get the answer right, like, you're here, like, okay, well, I'll just move things around, just be there. Show your steps, be detail oriented, be a little OCD, it's totally fine, right? Because that's when mistakes happen. If this is supposed to be down here and up there, or vice versa, whatever, just be careful. We punch this in, we get C, little c, right? Side C. So let's do that right now. Move it over here. Clear. 11 sine 48.96 divided by sine 105. Boom, boom, boom. Yeah, 8.58. That sounds good to me. I think it seems reasonable. In terms of rounding, I think 2 decimal places is fine. Don't worry about it. I'm not going to be a total stickler about it. And that makes sense because opposite the middle angle, right? The middle angle is 48.96. 8.5 is the middle side. 5 is opposite the smallest angle. 11 is opposite the biggest angle. So this all makes sense. That's law of sines. That's what law of sines does. So now hopefully you guys see what law of sines is doing for us. We've given some sides and angles. Either one angle, 2 sides. Draw it. Try to be as accurate as possible, to scale as possible. Just go through the motions. Like, okay, well, I know I have known angle side here. Yes, this, sorry, this and this. I know these two, right? Set it up. Why erase it? Set it up and set it equal to sine B over 5, solve for B, angle B, then solve this angle, then solve that. So there's gonna be about 3 separate calculations. I first find angle B, then angle C, and then side C. One the next. You can only find that it's not right. I'm not happy with it. It'd be impossible. I mean, you can drop the altitude, we got 90, but you really don't have this to be split precisely. You got anything else.
Yeah, I mean, if you could, great, but then I'm not gonna make a problem with that because they wouldn't have to use this. I want to force them to use this technique.
But yeah, that's what's happened. That's how it all. Yeah, so it's a lot of geometry for sure. Um, okay, so let's do the last example. Explain what's problem works out the way it does. Well, it just works. I don't know. I don't know why. We'll just move on. All right. Okay, so now there's one last thing we have to talk about. And this is going to be something called the ambiguous case. We'll talk about it in just a little bit. Now, there's a possibility that when you do this, that you might have to do do a second cycle of it. I know it sucks because there's a possibility that the triangle you drew may not be the only triangle it could be. It could be something else. Let's not worry about this the bottom of this page. Let me do example 4 with you guys, and then we'll fill out the table down below. Yeah, it's gonna be this one's gonna be a little intense. Okay. Ugh, I know, not terribly exciting stuff, but okay. Oh, by the way, pop my head. Who are the juniors in here? Yeah, okay. So are you guys planning to do the ACT later in the spring or SCT?
Yeah.
Okay. Well, SCT doesn't do this. I've never seen it. No, the SCT will be new, it'll be digital. Maybe they might do a problem. I don't know. The ACT has done stuff like this. I'll try to see if I can dig up some stuff from my files. The ACT, but they give you the formula, by the way. They will give you the formula or even tell you what to do. But they'll ask you to apply this formula. So just this can show up on standardized testing if you're doing ACT next month or in April or June or in the fall every senior year. So, and the seniors are laughing like, I don't have to do this anymore. So, yeah. They get, yes, ST. They do get Desmos. You're right. SCT does get Desmos.
They put Desmos
On the new SCT. Yeah. Yeah. It's all. Yeah. It took them a long time because the pandemic, they lost so much business, right? So anyway, let's keep going, guys. All right, here we go. I still hear it's hard to find a testing site though. Like people are traveling pretty far to go find a place to take it.
One of my friends drove all the way up to
Fresno or Sacramento or Modesto.
something. It was like a 4-hour drive. And
Oh,
they
geez.
spent the night
Yeah,
there.
that's horrible. That's awful. Was that a while ago? Oh, okay. Okay, so not like 3 years ago during the pandemic. Got it. Yeah, I had one student. He had to fly to Arizona because we were flying out of state because you couldn't take in California because all schools were closed, right? In 2021, 3 years ago. And he and his dad were gonna just make a weekend of it. And they said, let's go watch Arizona Diamondbacks. They were playing the Angels. They're going to see Shohei Ohtani pitch. It's going to be fun. And apparently they changed his testing site the night before, but he never got a notification or email. He shows up to that testing site. It's like, oh, well, you're actually not in this city. You're in a different city. And he just can't make it there in time. But he spent all this money flying out there. I was like, it was so ridiculous back during the pandemic. It was crazy. Absolutely nuts. All right, let's label here. Okay, here we go, guys. So let's work it out. Sine of 70 degrees over 155. So as you know, I'm doing a known angle side pair, right? I'm not getting too caught up.
Like you guys answer the formulas. I'm not even really using them. I'm just realizing I know these two go together. They're opposite, right? These go together. They're opposite. I don't have to use like, okay, let's play the angle A, little A. I don't worry about it. I just know
They're opposite each other. So just plug it in. And same thing here, sine B over 160. You don't have to get too caught up in the whole formula bit. So you have this. %, correct. Yes. I like to draw it as accurate as possible just to help me. And I'm not trying to help you guys. But yeah, if you kind of did it sloppily, it'll still be fine. Totally, 100%. 100%. Okay, I'm not gonna get too caught up in isolating B. Now you know I have to do an inverse sine. You guys just know that. So I'm gonna do inverse sine of 160 times sine of 70 Yes. Divided by 155. I get 75.93 degrees. Great. Awesome. 75.93 degrees. Which should be right here. However, there's a second scenario. It is. I skipped a step. You can get 104.97. Here's the reason why. If I do, well, first off, 160 times sine 70, I should have actually calculated that. Divided by 155 is 0.97, right? So the sine of 75.93 is 0.97. The sine of 104.97 is also, well, I kind of fudged it a little bit. Oh, 0.07. Oh my goodness. Sorry, guys. 07, my bad. Is also 0.97. Why is that? So sorry, that should be 0.07. Why is that? Well, remember what I said, sine is positive in both Q1 and Q2, right? Like, for example, 60 degrees. What's the sine of 60 degrees? Root 3 over 2, right? How about 120? Still root 3 over 2. And notice that 120 is a supplement of 60, right? So that's what I did. There's two possibilities here. 75.93 totally works, but if I plug in 104.07 into here, it would also work. Why? Because it's supplemented this, right? If you think about reference angles or equivalent angles in the second quadrant, it's still a valid answer. Remember we talked about when we were solving triangles, like we did that in the test, right? Like sine theta equals root 3 over 2. Like, what are the answers for that one? That would be 60 degrees or 120 degrees, right? Because the second quadrant will also be a valid answer. So you have to actually compute that. You have to. Whenever it's SSA, you have to actually look at the other scenario. So very, very important. So always for SSA, must consider the supplementary angle. You must consider the supplementary angle. Now, can 104.07 coexist with 70? Yeah. Is there enough room for 70 and 104.07? Yeah. So what this means is that this triangle was not the only possibility. Our triangle also could have looked like this. I know it's crazy. Our triangle could have let me so it could look like this. That's totally a possibility. So we say that this is ambiguous because there's another possibility that could work. It's a pain in the ass, but you have to kind of go through the motions and you have to kind of solve each case separately. Look good.
So that works
When it's SSA.
Yeah.
Yeah, 100%. Right. It can. You have to check. You have to check. Yes. So what I'm going to do is let's finish off the green triangle, then we'll do the black triangle. I know it's kind of a pain, but we just got to do it. So for the green triangle, you have 145.93 to 34.07 degrees. 0.07 degrees. And now I give you the law of sines one more time. So I'm gonna have sine of 34.07 over little c equals sine of 70 over 155. Cross multiply, work it out. I'm going to do this kind of quickly. 155 times sine 34.07. I know it's not terribly fun problems. I appreciate you guys' patience. Divide by 155. Wait. Divide by sine 70. I'm losing my mind here. See, told you. Sine 70. Thank you. And I can read that. 92.4. 92.4. Yeah. So what you would do is you kind of fill out all this stuff here. Let's see here. You could say, that was 92.4. What was that angle again? 34.07. And what was the other angle again?
75.
Thank you. And this was 104.07. And then you have to kind of figure out what that one's going to be. That's going to be 5.93 degrees. And then you have to do law of sine to get this. Sine of 5.93 degrees of little c. Sine of 70 over 155. If I work that out, I got cross multiply, divide by sine 70. So 17.04. Can happen. Can happen. And a rough sketch, this is probably more like that. This is like angle B, 1, angle A, angle C1. Or it could be an obtuse triangle. It could be like that. That's a possibility too. So you have to look for that. And the best way to look for it is if it's SSA, once you solve for the angle, do the supplement, see if it can coexist with all the other angles. If it's possible. If it's not, then forget it. Then just be one. Or if you get something really weird happening, like all of a sudden, like get some like you do inverse sine, so you get something really like a negative or just something really strange or greater than 1, then it's no triangle. That's also a possibility. So when given one angle, begin by finding the second angle. If the given angle, the one you just found, add the more 180, or at some point, no such triangle exists. Check the supplement. Sometimes you have one triangle or two triangles. Use law of sine to find remaining angles and sides, or make triangles possible in a given problem. So there we go. Okay, we're all set. Homework is just going to be this packet here.
Not the whole packet. This is the whole unit. It's the homework 36, 6.1. Numbers 1 through 8. So I'll open up the schools right now. You guys want to get started? Can, or you can wait till next time tomorrow night
Or early Friday morning, whatever works for you guys.